Hi everyone. In this video, let's look at Intel BE200 adapter, the eMLSR in action. So the plan is, I will connect this Intel BE200 client to a 9800 managed access point. So that's configured for both band to 80 megahertz, and see whether if traffic is going via one link, and then we'll try to introduce some interference to that link and see whether traffic is basically smoothly switching to the other link. That's the idea. So now let's go ahead and take a packet capture as well. Hopefully you will be able to see this in action. So let's take a packet capture. Now we'll set to 10 minutes, and then let's say Meraki 9800 BE200 eMLSR in action. So now start the capture. So now what I'm going to do is I will go to my remote desktop machine. I will go ahead and connect this to MRK-PSSID. So it's being connected. Now NetSH WLAN show interface. So you can see both connected, like a link ID 3 mean 6 GHz, 5F in channel number 5, link ID 1 mean in 5 GHz. So now, so you can see data rate will be 1297. So now if I check on the MCS index, let me just make sure that's tested as well. 1297. So you can see it's more like 80 megahertz, 80 megahertz, MCS index 12. Okay. So now that mean even though we have 80 plus 80, traffic is not going across both links. So now let's now in here I just want to make sure. Let me see whether route print and see whether now default route appear to be on the wired interface. So let me take that out. So now I have taken that out. That means I need to go to 130.26 kind of IP remote desktop. Probably I need to go with this interface. Yeah, so now if I look at the spectrum, now this is 6 gigahertz. So this is 5 gigahertz. Okay. So from my client, let me generate some traffic on my client. I have some YouTube video I can play. I'll minimize sound here. So now if I generating some traffic from my client, now let's see where the traffic is. It appear to be traffic is passing through a 6 gigahertz kind of link. Okay. Now ideally if I want to generate some traffic on the 6 gigahertz, I can log into this Meraki. Let me see whether I can go to Speedtest in here. In here as well, I have a wired connection built. So that way, let me just. So now I disconnect that wired connection. So probably my remote desktop as well. Probably momentarily maybe stop. So this should be re-established. You can see the connection was lost. Still traffic is going through the 5 gigahertz kind of link. Now ideally, like I would like to bring an interference here, but I don't have a 6 gigahertz kind of interferer. Yeah, this packet capture has been say part 1. Ideally, like I would like to get another capture because that's not really had enough. Yeah, still traffic is going here. So now if I do a speed test, see whether will traffic switching over to, I connect to the Meraki side and do a speed test. Now in here, I would like to see this one still, you can see traffic has been switched, a little bit of a traffic here. That's a good sign, but again, I don't know. Yeah, ideally this should be, we never know because we saw now 5 gigahertz traffic has been increased. So we'll check the MAC address of the client. Now we can see that speed test still going, but we can see some traffic here. Okay. Now the way we interpreting is, now if you look at the client, now let me stop this video playing. Now if you go here and test search show interface, now so you can see here this MAC address 54.60 is 5 gigahertz. Okay, so I have those MAC address value being copied. So 5 gigahertz is 54.60, 6 gigahertz is 50.4.5F. So what I'm going to do is I will just check now. Hopefully we can stop this capture. Hopefully it will be captured, like what we wanted. We saw some traffic switch. So in the part 2, so now I will open this part 2 file and I'll go to the statistics IO graph. Now in here, you can see 5F, which is my 6 gigahertz MAC. Let me double confirm that. 5F is 6 gigahertz MAC. Now, so now in here, we generate some traffic on Meraki side as well. So that's why you can see a lot of bandwidth there. But 5 gigahertz, so we saw some traffic. You can see here, if you, let me just take this off. And now this will show 2 band traffic. So you can see here, initially, certain traffic go through the 6 gigahertz. Let me just make sure I'm looking at the right sort of. Now 5F is 6 gigahertz. Okay, so you can see there's a 6 gigahertz traffic, and after some time you can see 5 gigahertz traffic has been increased. Now once the 5 gigahertz stop, and then again 6 gigahertz traffic started. Initially you didn't see any traffic to my 5 gigahertz kind of interface, and then 6 gigahertz traffic, pretty much going through, and then at some point, now the important part is, So there are any given time, there won't be traffic across both links. That means when the green line is showing some traffic, purple line is no traffic. So when the purple line shows some traffic, a green line almost no traffic. Okay, so that's a eMLSR behavior. So let's see whether we can, go to the frame level and understand the switchover. Now let's look at going through the two captures we took. So now, just before go the captures and analyze, now we understood, the Intel BE200 adapter, it's a eMLSR client. That means in a given time, it can only transmit across one link. So now how do we change the traffic between the links? That's the important part. I think that's what we saw in this particular capture. Initially client sending traffic in 6 GHz. Once we make that channel busy using Speedtest on another SSID on the same channel, so we saw traffic switch into the 5 GHz. So now the eMLSR operation point of view. So now in the IEEE 11BE amendment, they given some examples of how this particular packet exchange works. So now one option is we have to send the initial control frame. So it can be a multi-user RTS frame, or it can be a buffer status report poll frame as well. So that can be depending on the implementation. So we sending a MU-RTS frame. So example, now if traffic going 6 GHz, if AP want to switch traffic to 5 GHz, so they will sending a MU-RTS frame on the 5 GHz link. Now, if that to work, client should have the capability of listening both radio. In that way, both band, a single radio, but it should be able to, for example, if it's a 2x2 kind of radio, in the listening mode, so client should be able to split that radio into two 1x1. So one listening for 5 GHz, one listening for 6 GHz for a short period of time. So now when that particular frame goes, if client is happy to receiving traffic on 5 GHz, so they will do the clear to send, and then access point will send a data frame and switch the traffic to the 5 GHz band. That's a one sort of a method, in the further enhancement of that particular method, what we can do is, we can get some sounding. That means just to, before sending the data frame, we need to get a feedback matrix, how client receiving these frames. In that way, AP can enhance a sort of a signal for the receiver. So in that way, still same multi-use RTS frame and CTS frame. Before sending the data, we are doing the EHT NDP announcement and get the feedback matrix from the client device. Okay, so in that way, now what we'll do is we'll go to the frame captures we capture and see whether we can understand any of these things happen in our scenario. So now first I will go to the part 1 of the frame. We basically, now this is sort of part 1 of the frame. So now in here, if you want to identify, is there any client association, especially with the multi-link element included? So I have a filter here, Wi-Fi 7 multi-link association request. If it is a multi-link single radio or multi-link multi-radio. Now if you check multi-link single radio, there's a one association. There are no association regarding multi-link multi-radio. So how we differentiate this? If we look at this association request frame, so we are looking at that multi-link element. There's a sort of element we are caring about. So in this element, there's something called common info. In this common info, you have multi-link capability, EML capability. So now in here, multi-link capability, this is the differentiator. So if this value is 0, that indicating, so client can only transmit or receive across one link. This value 0 mean one link. So that's clearly telling it's a multi-link single radio. But this client has a EML capability, enhanced multi-link capability. So if you see this element in that particular common info, that indicating he has a enhanced multi-link single radio capability. You can see this bit set to 1. Sometime if it is a multi-radio enhanced capability, so this will be with 1 instead of this one. Okay, so in that way now this is a multi-link single radio with enhanced capability. So this proving is a eMLSR client. So now in here EML capability, they will listing those transition delay. That mean like how much like we are going to listening mode, and then following the data transmission, what is the sort of a transition delay. Those timing indicate advertised in this particular field in here. So now if I basically like for example I want to find out now this is my 6 gigahertz kind of, you can see channel number 5. So initial association came across 5 gigahertz kind of link. Now within the same sort of a multi-link element, so they may be like indicating I would like to bring like link ID 1, which is the 5 gigahertz. Okay, so in that way 5460. So now let me just see whether I can show you this in the notepad. Now 5460, probably this will be 5 gigahertz. This is my 6 gigahertz. MAC address 545F, and then in here you should see in the common info section my multi-link MAC address as well. So that's the upper link MAC address 545C. In that way now you can see client point of view all these MAC addresses value. So now if you want to filter traffic from these MAC addresses, or these are the link specific MAC addresses, you can find the details. So now if I want to filter wlan.address, either if I filter for this, or if I put that, probably you can type O like this in the Wireshark filter. Now this one will be 5460. So this will filter all your traffic either going to client 6 gigahertz link specific address or 5 gigahertz, because in this scenario SSID is a dual band. So only possibility is if a traffic goes to client, it has to go to these link specific addresses. Now if I put that filter here, now this is pretty much what you can see here. Now if you in that way even traffic switch to 149, we should be able to see. Okay, so now in here if you scroll down, I am paying attention for channel column. Even the spectrum analysis we saw, it did not really switch traffic to 5 gigahertz band in this particular first part of the capture. So you can see it is pretty much 5 gigahertz. Okay, no switching to the 6 gigahertz. But now if you understand sometime like now you can see here authentication, association request, association response, 4-way handshake, and data frames goes. Okay, so now typically now in association, probably you will authentication, you normally should see a 4 authentication frame if you are doing SA authentication. So sometime you may be wondering why we basically having a 6 authentication frame, but if you pay attention closely, you will see initially client basically, if I look at the first authentication frame, client sending a SA authentication frame, but he is using a 384-bit elliptic curve. That's the group he want to use, and then AP responding, authentication is rejected because of a finite cyclic loop, group is not supported. And then client basically trying 256-bit, okay, elliptic curve, then it is successful. So you can see everything is good, works well after that. In that way, that's why the 6 authentication frame. Then he's sending a association request with the multi-link element included. You can see here. So listing, can I bring 5 gigahertz to this multi-link association? And then you need to look at association response and see whether AP happy with that, and still you need to look at that multi-link element. In here, multi-link element, probably if you look at the per station profile, you can see status code successful. That means AP indicating I am happy to you to bring 5 GHz into this MLO association. Okay, so now 4-way handshake take place, and you can see M1, M2, M3, M4, and data traffic goes. You can see after some time, those data frame speeds are like a higher MCS kind of rate value. Okay, 648, those kind of. But in here, important part is traffic still going through the 6 GHz link. Now let's open the other capture, which is let me open the part 2 of this capture. Now this is the part 2. So now if I filter the same sort of a filter, I'm looking for this. Now you can see initially, traffic is still going on 5 GHz, channel number 5, which is 6 GHz kind of channel. And then after some time, if I scroll down here, so you can see traffic is switching. Okay, traffic is switching from channel 5 to channel 149. That means 6 GHz to 5 GHz. So this is the initial time. It's basically changing. Now, in this particular scenario, so now in here, I have filtered for the client MAC addresses. Okay. In that way, that initial control frame, sometime it may be not go to directly to the individual client MAC address. So in that way, we have to basically, modify this filter to see all the packet. But now in here, whenever that channel change occur, you can see certain kind of frames here, NDP announcement frame. That's what we talked about, if you remember. Now let me just go back to NDP announcement kind of frame. So it appear to be, we are using a second kind of example here. We should see the MU-RTS CTS frame and NDP announcement, and then so now if I probably remove any of these particular filters, I should be able to see the proper flow of traffic. For example, now before this NDP announcement, frame number 3584, I remove this filter and see what's exactly happening there. Okay, now you can see here channel number 5. So now you can see now in this particular area, so now we say frame number 3580. So AP is sending a multi-user RTS frame. Okay, so if you look carefully, that frame goes 6 Mbps. So now this is 6 Mbps, mean one of the lowest data rate. Now if you expanding this user info section, user info, you will have your AID value. In that way, now this frame goes to a broadcast address. That means if my Intel client, if the AID value is this, so then the Intel client supposed to acknowledge this and sending a clear to send kind of frame. Now you can see we are using a one special stream. This is the receiving kind of mode where client devices go one by one kind of scenario. So they should be able to listen this control frame either of the band. Okay, so even we are saying traffic transmission goes only one band, a limited time a client can receive in both band. So this is called the initial control frame, ICF. So now then you can see client basically acknowledging that. clear to send. Let me see whether any other information here. Now it says here HE trigger frame, the detail of that. Yeah, other than that, nothing sort of a really significant detail there in the previous frame. So this initial control frame, client basically acknowledging. Okay. So now in this example, I can see, like that's basically twice that initial control frame goes. Like ideally not too sure whether it, why it is sending 2 times, but I can see MU-RTS frame 2 times on the same channel, 149, 149. So now, and then you can see NDP announcement kind of frame. Okay. Now then AP is saying, you basically provide me the, now in here, it listed the AID value, of the client who's need to provide the NDP, so now this is like a sounding kind of, and then next frame is, you can see, now typically if you go back to the packet capture here, then AP sending a null data packet, NDP, sounding NDP. This is typically doesn't have any MAC header. In that way, this frame typically you cannot see in a protocol analyzer. Okay, in that way we see this one, but we don't see this kind of NDP because this is like a trigger kind of frame, no MAC layer header detail. So it's basically giving an indication to the client devices, send you a feedback matrix. So now you can see here, after that, action this no acknowledgement kind of frame. If you go into the detail, or what is this particular frame? So this is compress being forming. Okay. So he's sending all those feedback metrics. That means 996 tone RU. He's saying how they hear all these subcarriers. So this is giving a feedback. This is not a real data frame. This is basically clients providing a feedback for that null data packet, how he is hearing AP's signal. So this will help AP to beamform signal to that particular client. So that way now you can see that, and then what happened. So now after that, you can see, AP sending a data packet, QoS data with 1080 kind of data rate value, 1080 Mbps data rate and block acknowledgement. Now you can see, still, after that, he's sending one frame, and then again, went back to, now this one sometime don't get confused. So sometime, you need to make sure he's passing certain data frame, and then still, little bit of a data in 149, and then again went back to, you can see here, channel 5, and then passing still channel 5. So let me see the proper place where we can see channel 149 being used. Okay, now again, now don't get confused, if I confuse you here. Now what we did initiate the traffic on the, now we are monitoring this in the 9800 kind of access point, and then we generate some 6 GHz speed test on the Meraki access point. In that way, now this is Meraki 3D90. Now if I go back, my 9178 AP BSS IDs are this one. Okay, in that way, now simply without any filter, if you look, that may be sometime confusing because I generated some 6 GHz traffic on a different SSID managed by Meraki. In that way, now if you want to filter this particular traffic, ideally if you look at the IO statistics graph from 5 gigahertz, and 6 gigahertz MAC addresses. So you should be able to clearly see this. Let me just go to the IO graphs, and you can see here. Now I am 545F, which is my 6 gigahertz. 545F, 6 gigahertz, green color. 5460 is purple color, which is my 5 gigahertz. So now you can see traffic is going 6 gigahertz, and after some time we switch the traffic to 5 gigahertz kind of band. Okay, when traffic goes 5 gigahertz, the green line is flat, 0, no traffic, and then when that stop, again 6 gigahertz getting spike. So data frame point of view, data frame always goes one of these kind of band, not simultaneously go across the both band. So now if you really, without getting confusing, so if you want to filter, I think the best way to filter is we will look at my BSS ID. Okay, so what I need to filter is traffic coming from either this one or that one. Okay, so now what I can do is, let me just see whether I can create a filter for easily see our interesting traffic. So I'm looking from, because in this particular scenario, I only have one client in the AP. In that way, even if I monitor AP BSS ID, this should be, because I don't have multiple client associated. So this is signifying a single kind of traffic as well. In that way, if I look at this will remember this 3584. Okay, that's a sort of a area we are interesting. 3584. Okay, now if I remove the 3584, so this frame should be there, even if I filter 6BEE. Yeah, 6BEE. WLAN address equal to that, or WLAN address. Okay, so that's interesting thing. I will not see that frame. 3584. Okay, so now when I remove that, I can see 3584, but this one also go from the transmitter address. Let's put this one like this, WLAN, let's say .addr. Okay, so now this one appear to be a different MAC address. Let me just check why it is slightly different. You can see it is sending ED. It's not exactly same EC. In that way, so I just need to check that. Okay, but at least you get some, this is slightly different MAC address, but that is appear to be sending this NDP announcement kind of frame. Pretty much that MAC address keeps sending the NDP announcement, slightly, like a different MAC address. I need to find it out, why it is sending that MAC address, but this is definitely appear to be, if it is any without any filter, you see. Okay, so now the other way of, if you really want to filter traffic only to applicable to your client, what we can do is, so we can filter by let me just copy this MAC address. This should be same as client MAC address. Let me just put that one as well. Yeah, that's definitely my client MAC address. You can see A202. So that way now one option is probably we can filter by this, or sometime I need to filter by traffic go to broadcast address. Okay, but that will basically getting unwanted traffic. I want to only control this control frame, or traffic goes to these MAC addresses. Okay, let's filter like this. I filter like this. I want traffic goes to this, or if I filter control traffic, I want this kind of control traffic. Okay, so now what's the easier way to filter? So I can filter control traffic, apply filter, whatever the current filter, and select it. Okay, let's see. Oh, basically I think here, not oh. Probably let's get rid of this. Now this is either this MAC address or control frame. So if I filter that, let's see whether now you can see the, but then this will not take the data frame. Okay, so now I want, okay, let's see. I don't want the, yeah, sometime I think like it may be a bit difficult to like get exactly the frame. Now in here I filter the control frame, then it filters the control frame, and then it will be filtered out data frame. Okay, so now you can see here, it's changing traffic and go to channel 149, because now this is filtered out certain frame. You can see now this is where the traffic switching happened, but we don't get all the frame. If I filter by the client MAC addresses, yeah, ideally what I want to see is 3584. Now there are no filtered here. Now this is the time traffic switching happened. So I want to filter this multi-user initial control frame. Okay, that means I need to get this broadcast kind of frame that will so I will look at that, at least I have a good filter where the interesting traffic can be filtered, but you can see here in that way, you saw in that way. Now to summarize, like what we discussed in the eMLSR action point of view, once, a traffic, eMLSR operation is going on, if you want to switch the traffic, you have to send this initial control frame. So those control frames sending in the lowest data rate, 6 Mbps or 12 Mbps or even 24 Mbps, one of those data rate need to be used. At that particular time, client need to listen for both band. So how they listen both band? If they have a single radio, they break that higher capacity radio in the lower capacity like a 1 by 1 listening mode. In that way, 1 by 1 mode, you can listen 6 GHz band, 5 GHz band, and then see whether this initial control frame is coming. And if client is happy to switch to that particular band traffic transmission, he will be acknowledging that. And we saw basically in our Intel BE200 scenario, we are doing some sounding as well, and client giving feedback, and then we transmit the traffic in the new band. So now, just before we finish, now in here, if you let me just filter our filter one more time, at least this client MAC address filter, because I want to find out my interesting client traffic. Now you can see he's transmitting traffic on 5 GHz and switching to 149 very first time, around that 3584 kind of mark, and then traffic go 149, mostly 149, and switch back to channel 5 around 59626 kind of time. Now in here, in this particular time, if I take it back 59, now you can see channel number 59626. This is the sort of time we saw. Now in this particular scenario, what we saw is actually we didn't really see. Now we can see some sounding kind of packet, but in here, immediately what they did, 59626. So my client is sending a null data packet. If we look at the frame control, if you expanding the flag value, he say, hey, I am just bringing my 6 GHz links up, and then pretty much like a power save mode. He's saying that, hey, I'm not power saving on this link. So it is sending traffic previously, yes, in that way, if you filter the traffic for the client MAC addresses point of view, you saw. Now this is my either 6 GHz or 5 GHz, 59626. So that's a sort of a frame. Previously, it's sending to 5460, 5460. So now WLAN address change into that particular frame, and then you can see traffic goes QoS data and all this kind of data. Like a 630, 631, 632. That's a sort of a initial block of data. In that way, now frame flow point of view, you can see my client telling access point, hey, I would like to switch back to 6 GHz. So in that particular scenario, we didn't see that client sending, initial control frame kind of thing. They're simply bringing, 6 GHz link, not power save kind of mode. And then, request to send, clear to send just like a normal kind of communication. And then immediately he's sending traffic to 6 GHz back. Okay. So now, since then, pretty much, now we are doing some sounding, access point doing sounding kind of communication. So we see the traffic goes back to 5 channel number 5 in 6 GHz. So hopefully, you got a good understanding. Now I think in that way, this is sort of a very important capture. If you are really keen to understand eMLSR behavior, so sometime it's very difficult to produce this as well. Sometime depending on the condition you make, so sometime you may not able to capture as well. Sometime I tried many times, and after a lot of sort of attempts, I got this at least to tell exactly what's happening in the eMLSR behavior. So in that way, use this capture for your understanding of analyzing wireless 7, Wi-Fi 7. Until I see you in another video, take care.